Okay guys, so what we're going to look at is the chain rule with trig functions. So I learned this a couple of years ago, not the trig function chain rule stuff, but a way to help you guys remember what to do on the chain rule with trig functions. So you need to think of PTA. That'll help you figure out what to do, of course. I can't even write an A correctly. There we go, PTA. So what this stands for is power, trig, angle. So PTA, power trig angle, not parent teacher association, power trig angle. And it really does help. When I saw it a couple years ago on like Twitter or Pinterest or something, I thought I wish I would have known that when I was in high school taking calculus. So let's look at a function. Let's use sine. So we know that sine, if we want the derivative of that, is cosine. That one's the basic parent function, so we don't need PTA. Let's try this. What if I have y equals the sine of 4x? Now this one is a composite function because 4x is not the parent function. So when we take the derivative, we have to think of PTA. First of all, is there a power? There's not a power. Technically it's 1, but there's not. So there's not a power. Now we do the trig. So what is the derivative of sine? The derivative of sine is cosine. Keep the angle. Then we multiply. So these are all multiplied, by the way. You take the derivative of the trig function, which we did, which was cosine. You kept the angle, which is 4x. And now we multiply by the derivative of the angle. So the derivative of 4x is 4. You could rewrite that as 4 cosine 4x. Let's try one. I'm just going to use sine for all these. It works with any of the trig functions. Let's say we have the sine to the third of x. So again, it's complex because now we're not just sine, we actually have the sine function cubed, not the angle cubed, but the sine function cubed. So we go up here to PTA, so we start with the power. The power is 3. Sorry, the power is 3. The power rule says you put that in front. So my derivative is going to be 3 sine. We subtract 1 from that power, so that's squared of x. So we did the power. Now we have to multiply by the derivative of the trig function. So now we do the trig function next. So the trig function is sine. So the derivative of sine is cosine of the angle is x. And then we multiply by the derivative of the angle. So the angle is x. So the derivative of x is just 1. So when I rewrite all that, I get 3 sine squared x cosine of x. And that is your derivative. So when we're doing this PTA, what you need to think, I'm going to write kind of a complex one up here and just try to show you each part. So let's say it's the sine cubed of 5x. So when I say power trig angle, the power is this, the 3. The trig function would be whatever the trig function is. This time it happens to be sine. The angle is the 5x. So you have power, trig function, angle, PTA, PTA. And each time you do that part. So some of these, I actually could do the chain rule more than once on these. So it could have 2 chains. All right. Let's just try this one. I'm going to go down here and just rewrite this one I did. Y equals sine cubed of 5x. All right, so when we look at this, the derivative, we start with the power. So the power is 3, so that power goes in front, 3 sine, and that power becomes 2 of 5x. So everything else stayed the same. The only thing I changed was the power. We multiply by, now we're at the t, the trig function. So the trig function is sine. Now, it's just sine, not sine cubed. So the derivative of just sine is cosine of the angle, which is 5x. And then we have, so we did the power, we did the trig, so we did pt. Now we need the derivative of the angle. So the angle of this is 5x. What's the derivative of 5x? It's 5. So my answer, if I simplify, is going to be 15, because I can put these two together. Sine squared of 5x times the cosine of 5x. So that's a problem where we use both the chain rule. Actually, we did the chain rule twice, because technically this part was a chain, was extra, and so was this. So that one had the chain rule twice. Let's look at just one. Here's a problem that I see a lot in every calc thing that I look at. Sine of 2x times the cosine of 3x. That's your function. So in order to do this, you notice that there's two different trig functions and they're being multiplied. So this one's going to be product rule. I know you're excited. And chain rule. So let's start with the product rule. So the derivative, we're going to start with sine. So it's PTA. We're going to do PTA for both of these as we do this. So we're going to do this one first because that's what the product rule says. So there is no power. So I go right to the sine, the trig function. So the derivative of sine is cosine of 2x. So trig, and now we have the a. What's the derivative of the 2x? That would be 2. So that's the derivative of just sine of 2x. Then the product rule says I need to multiply that by the second part. So that would be multiplied by the cosine of 3x plus, now I'm going to keep the sine of 2x. And now I need to do the derivative of this. So is there a power? No. So now we do the trig function. What's the derivative of cosine? Get negative sine, keep the angle, multiplied by the derivative of the angle, which is 3. Now we're just going to simplify that. Looking at this, be careful simplifying. This 2 is a coefficient. It doesn't go with the angle. So I get 2 cosine of 2x, cosine of 3x, minus, because this negative can come in front, 3 sine of 2x, cosine of 2x. So there's some examples. If you're not in class, also I'll try to put a couple videos from the book on there.